Hello guys, welcome back. This is Krishna again and welcome to AI Martian. So guys, we were talking about activation function. There was 5 activation function which I have mentioned in the list of Google Colab sheet, which I will show you right away. So in that I mentioned Sigmoid, Softmax, 10H. Then I'm talking about ReLU today because this session is all about ReLU. What is ReLU and why it is helpful to us? Because there was a lot of problem. There was a problem like vanishing gradient. I coined a few times this name in my previous lecture as well, but I didn't explain it. And I'm not going to explain vanishing gradient now also because it is not a right moment to talk about. Okay, so I will talk about it later on, but not today. So today I'm just talking about the functioning and definition or the uses of ReLU. Okay, why it is most popular. Okay, Sigmoid, ReLU, and Tanh. These activation function use processing capacity of a machine. So to get rid of this kind of problem, researcher thought about to introduce a new activation function, and that is ReLU. Now, how ReLU work? What are the mathematical logic behind the ReLU activation function? I'm going to teach you in this series. Okay, so let's move ahead and go to Google Colab sheet. So guys, here I have mentioned about activation function. So today I'm going to talk about ReLU, which is rectified linear unit. All right, let me create a shell for this, and there I will mention the thing and make a heading of this. All right, so ReLU, what is ReLU? What are mathematical concept behind this? How it works? So I'm just going to take one simple example right away, just to make you understand, and I will draw something on the screen. So suppose you have a toy. Okay, you have a toy. This toy name is ReLU. Okay, ReLU. It's a ReLU toy. Okay, it only know two things. Whenever a user, suppose this is me, Krishna. Okay, whenever Krishna give any number to this toy, okay, whenever Krishna give any number to this toy simply give two answers only. One is 0 and another is the same value what I ask. Okay, suppose I'm saying 10, it will simply tell me 10. Okay, suppose if I will say 11, it will give me 11. Suppose if I will say minus 10, in that case, it will give me 0. Suppose if I will say minus 0.001, it will simply give me 0. Okay, so this is a kind of toy who only provide us two kind of answer. The first one, if the number are positive, it will simply give us a positive value, the same value as it is. Okay, but if the number is minus 10, or let's say the number is minus 0.001, in that case it will simply give me like a 0. Okay, so there is a function of ReLU which is mentioned is, let's say this is ReLU function, it will always give us 0 comma x. Now there is some conditions. So if the value of x is greater than equal to 0, it will give us the same value as it is. You can say x it will return. Okay, but if the value of x is less than 0, it will simply give us 0 in that case. So there are two conditions only. Okay, so why it is required? Okay, so basically a kind of problem start happening in machine learning training, that is called I'm just mentioning here problem. Okay, there was a problem, vanishing gradient vanishing gradient problem. Okay, now what it is, so think about it. Let's say I just want to show you something. Okay, I already taught you about sigmoid and 10H, right? So let's talk about sigmoid first. Okay, in sigmoid, the function we have is like let's say sigmoid is 1 upon 1 plus e to the power minus z. Now what is z? Z is nothing but, suppose this is a neuron summation part is z. Okay, so neuron summation part is z, and here we are implementing sigmoid, right, which is used to represent something like this. This is the kind of symbol which is used to represent activation function in a neural network. Okay, so we are talking about a single neuron. So this is a single neuron. Okay, so in this single neuron there are two parts, summation part and activation part. In activation part, let's say I'm using sigmoid. So what will happen? So whatever summation part I will get, let's say z, so let's say z is 3. Okay, if I will pass 3 here, it will simply transform that value, okay, between 0 and 1. Okay, so suppose if I have a graph something like this, I will say the graph will be look like this. It will be look like, one second, it will be look like this. Okay, a simple S. Okay, now what is this? What is the range? This is 0 and this is 1. So whatever value I'm providing to this activation function, it simply transform. Let's say this 3, if I will supply to this activation function over here, it will simply convert it between 0 and 1, and that value lies between 0 and 1 on this graph. So this is simply nothing but a sigmoid graph. Okay, sigmoid graph. Now think about it. Here we are doing a lot of computation. I'm simply passing 1. Okay, then I'm dividing that 1 by 1 plus e to the power minus z. Now again, I have to first calculate the value of e, that is 2 point something, right? And then I have to calculate the power of this value. Okay, and then I have to add that value with 1 and divide this number. Okay, so this is a really complicated kind of operation which we are performing. Let's say we are performing this operation n number of time, means 1000 time, 2000 time. So that's actually use a lot of computation capacity of our machine, and our machine may not able to process that all data at once, right? So in that case, we are not able to train our model. This is the first problem. So what I can say is, computation is very expensive. Expensive, I told you. Expensive means it takes a lot of memory, okay, to process the task, to calculate the value. If we have, let's say, more than 1000 neuron, and in each neuron I'm passing the sigmoid, and in each sigmoid there are such kind of value, there are z. Okay, so it will do 1000 time calculation of the same kind of operation. Okay, with different values. So in that case, it will do a lot of computation, it will do a lot of calculation, and that's why it will become very expensive computation wise. Okay, means it will overload our RAM, it will overload our memory. Okay, and in few cases maybe our process stop working, or the kernel stop working of Google Colab or Jupyter, and we will not get the output of our trained model. Okay, so this is very expensive. This is the first problem of sigmoid or 10h. 10h is also same. Okay, 10h also transform data between -1 to 1. Okay, so it is also same like this sigmoid. Okay, so these two, sigmoid and 10h, this is, I'm talking about 10h. Okay, this is 10h. 10h simply convert value between -1 and 1. Okay, so this is also quite complicated, and it is very much complicated to compute. It is very expensive. So this is the very first point which we have to keep in mind. And a scientist and researcher also got a lot of complications while training their model because of such kind of use computation. So they start thinking about a new kind of activation function. So they came across this ReLU. Now what ReLU says? Suppose what we are doing here, we are simply providing a value, and that value get converted between either 0 and 1 in sigmoid, or -1 between -1 to 1 in 10H. So in both cases, the machine is doing a lot of computation to convert our summation part, which is Z, to transform them between 0 and 1. Okay, just to learn the pattern of the neural network of the data set. Okay, using neural network. Now, ReLU also do the same, but in different way. Its graph looks something like this. Let me take another color. So it's something like this. Okay, what does that mean now? So this is 0. Okay, this is 0. Okay, this point where I'm cutting this x and y axis, where coordinate is 0, 0. From that point onward toward x-axis, it's simply going straight. Okay, it is simply going straight upward. Okay, so what does that mean? So that means if the value of x is greater than or equal to 0, it will give you x. So if I will put some value in this formula, what will I get? Let's say x value is 5. So 5 is greater than or equal to 0, is it? So I will get 5 as an output. Okay, similarly, if I will say, let's say this time -1. Okay, so if I will put here -1, so -1 is less than 0. In that case, I will get 0. In that case, I will get 0. I will not get -1. I will get 0, because -1 is less than 0, right? So whatever value I'm getting less than 0, it will simply return that value. Okay, so that's why this line which you are looking on the negative x side, it is simply flatten over the x-axis. Okay, so it also gives us two kind of output. It first gives us, if the value is a negative, okay, it will simply gives us a value called 0, or if the value is positive, it will return the same value as it is. See, so this is the use of activation function rel. Okay, now because of this kind of simple equation, it is, you can say, less computational. Okay, it is using less memory to compute. Okay, to grab the pattern from the data set using neural network. Okay, so this is less computational. That means it is more efficient than sigmoid and 10H, right? And that's why people start using this very frequently, and this is also used in our neural network, which I have created very first time before starting the whole sequence. Okay, so let me show you that. Yeah, so this is our neural network over here. Let me clean the screen. I'm cleaning the screen. So see, I am using ReLU here. Okay, so I'm also using ReLU. Okay, ReLU is very much popular, but at outer layer I use Sigmoid, because I have to find out the probability, because there were two classes only. If you didn't go through this video, this is the very first video of the coding round, okay, in this sequence. So first go through that. If you didn't go through, please go through that, and you will definitely understand what I'm talking about. Okay, so this is nothing but ReLU I'm using here. Okay, because this is less computational, this is faster, and people use so much in industry as well to get the desired output to train their model faster. They use ReLU. Their mathematical formula is also simple, which I have already shown you. So let me bring all the images back. So I mentioned vanishing gradient problem, but I'm not going to teach you right now because to make you understand about vanishing gradient problem, I will make you understand about vanishing gradient in separate video. So don't worry. For now, I'm just talking about ReLU. So I'm just mentioning about it. So ReLU, let's say ReLU is a function. Okay. So it simply have a theorem like it return x if x is greater than or equal to 0. Okay. In that case, it will return x. Okay. Whereas, let me make the font bigger. Yeah, this is fine, I guess. So ReLU, again, let's say I'm passing negative value this time. So in this case, it will return 0 if x is less than, only less than, not equal to, less than 0. In that case, it will simply return me a value called 0. Okay. So this is very simple kind of equation, you can say, which we are using in this. So guys, in this video, I teach you about ReLU activation function, which is most popular. Most of the time people use activation function. There are some more parameters like learning rate and all, vanishing gradient problem, why people use activation function. When I will teach you about vanishing gradient problem, back propagation, then again I will come on these topic and I will let you know why people prefer LU most as compared to Tanh and Sigmoid. All right. So that's all for this video. Hope you guys like this video. If you really like this video, please do like, share, subscribe, share with your friend, families, and give me a thumbs up in the comment section. Thank you guys. Thank you very much. And stay tuned, stay learning. Thank you guys.